Hi and welcome to this tutorial on how to use the Pathfinder feature to help you build tolerance stacks faster and simpler, and quickly check to see if you have competing paths that will increase your design risk. Let's get to it. I will go ahead and create a new calculation right away. I will name it, and I will just go with the auto ID, but I could also choose a specific one if I wanted to. So I now have a blank calculation sheet. To get me started fast and simple, I will choose the built-in Pathfinder. Here, I can select which parts I want to build my chain between. In this case, it will be the spout and the base. I am interested in the height between them, to make sure I can fit my homemade pottery cup when making my brew, so I will choose the Z direction as the input. Here, we can see that the algorithms found two possible paths for me. This is a valuable help, since the paths detected are not based on your assembly mates or any other idealized information. We find the paths based on the actual geometry in your model. So if you accidentally created a design that could have multiple force or tolerance paths competing to create your function, this will show up here. For this tutorial, I will not do anything about my unwanted path and focus on completing my needed calculation. The Pathfinder automatically creates a list of blank parameters that I can assign values and start calculating with. Before I start, I want to make an illustration of my problem to help me keep an overview. You will notice that the system now knows which parts are relevant for my calculation, so I can switch to an isolated view and reduce visual noise. I am going to go ahead and take a snapshot using the built-in 3D viewer. I know I am going to need an additional image to see the connection from the body to the boiler, so I will add that too. I will also put in a small overview picture, just for clarity. I am now ready to start my illustrating. I will start by indicating my point of interest. You can see that I get an auto snap feature based on my drawing direction. I will adjust the direction to be vertical in this case, and voila, I now get nice aligned lines in my representation. To keep a clean illustration, I use the help lines to avoid having annotations on top of my geometry pictures. Now, I simply connect my arrows. Notice that they are automatically associated to my parameters. Coming from the center axis, I realize that I need a close-up illustration of my gasket and the interfaces here. I can quickly add additional illustration from my 3D model or anything else and paste it to my canvas. I can now also see that I got my point of interest slightly wrong from the beginning. I can quickly adjust it to make my illustration correct. All done. I can now use another practical feature for stack-ups. The green button here auto-generates my calculation expression, my transfer function, based on my illustration. With a useful illustration of my design challenge and the transfer function in place, all I need are some numbers. I can put in my numbers manually, but here I have cheated ahead and will reuse some existing drawing parameters. You can also get a sneak peek at another useful feature. Notice that we assess the IT tolerance grade for each parameter, to give an indication of whether you are straining your process or not. I can now start to look at the results. I am looking for a nominal clearance of 70 mm and an accepted range of ±1 mm. I will also use the RSS calculation method, as I have a multi-parameter stack. The RD8 platform supports multiple calculation types and parameter distributions, but more on that later. With everything in place, I can now see that I got my signs mixed up. It is easy to change the positive direction, so I will adjust and update my expression once more. Much better. With everything in place, I am all done, and I can see that my calculation passes my criterion. I will finish off by using the tagging system to add valuable metadata and searchability to my calculation before approving my calculation. Thank you for watching. If you are curious about how the RD8 platform can make a difference in your engineering design work, then get in touch. Go to RD8.ai. We look forward to exploring your design challenges.
Do you know the quality of your designs? We do.